All right, and we're going to continue our conversation with our next lesson in our unit on transformations, and that is going to be on reflections. All right, and you can see that this is standard 11.2. I can reflect figures in the coordinate plane over horizontal and vertical lines. So to get you kind of thinking about what a reflection is, we have our opener here. So what I'd like you to do, all right, is go ahead and pause the video, all right, and do the opener here. So looking at our figure here, all right, and it has been transformed to here. Remember, our original original figure, all right, does not have the primes on it, all right, so it's just regular letters. So we know the transformed figure is always the, all right, figure with the primes on the letters. So is this a translation? Why or why not? And just kind of describe what's happening. Flip the video back on and we'll discuss that. All right, so notice we know it's not a translation because if it's a translation, it would still be in the same orientation, right? So notice when I go from this, the shaded side here, to the non-shaded figure over here, right, it's flipped, right? And it is reflected, right? Okay, so we know when we translate things, they don't change, all right, orientation. Okay, so if my pen is pointing to the right, okay, it'll still be pointing to the right no matter where I translate it, all right? But in this case, that is not the case. So this is a reflection, all right? And if you notice, it is reflected over the y-axis here, all right? So it's just like we flipped it right over, all right, that y-axis there, which, all right, leads us to our vocabulary down here. And so what is a reflection? Well, a reflection is a mirror, right, image of a shape, right, or figure, all right, over a horizontal or vertical line, all right? And so we're just going to take that image and reflect it over a horizontal vertical line. So that could be the y-axis like we did up here, it could be the x-axis, or it could be any other, right, horizontal or vertical line, all right? So for example, let's say we have a triangle like this. We have this horizontal line. So if we want to reflect it over that horizontal line, it would look just like it would be here, but just like a mirror image. All right, if we had a, all right, vertical line, something like this, all right, it would look like that. All right, so we would just reflect it over that line. Okay, now, so just a quick reminder, we've done a lot of work with horizontal and vertical lines this year, but all right, so remember, all right, a horizontal line is a line of the form y equals b. All right, my writing is struggling a little bit this morning. All right, a line of the form y equals b, right? So if we think about in our coordinate plane, right, there's our axis, right? So we could have a line like that, then maybe that's like y equals 3, something like that, right? While a vertical line is a line of the form x equals a. All right, so once again, if we go back into our coordinate plane here, all right, so maybe I have a line like that, right? Maybe like x equals -4, something like that. All right, so, and that's all we're going to do. We'll reflect over horizontal or vertical lines. All right, now, you may have picked up on this a little bit. So if I go up here and notice in our reflection, right, if we're reflecting over this, right, it really is like I could take my paper here and I could fold it over that line of reflection and everything would match up, right? So C and C prime would match up, D and D prime would match up, G and G prime would match up. And the only way that can happen, all right, is if the distance between the pre-image and the image, all right, is the same on both sides of the line of reflection. All right, so notice the spacing here. It's 1 away, 1 away, 2 away, 2 away, right? 3 away, 3 away, right? 5 away, 5 away, right? So that's the key there, right? And also notice that our reflection is still in isometry, right? Distance, all right, and the shape is preserved, right? It doesn't get bigger, it doesn't get smaller. All right, so let's flip the page here, all right, and, all right, do just a little bit more here, right? So a reflection is a transformation that uses a line like, in this case, a line like M, right, to reflect a figure. All right, so you can see we're just reflecting this triangle ABC over line M, and we get triangle A prime, B prime, C prime. And once again, you can see that A is 2 units away, A prime is 2 units away, B is 1 above, B prime is 1 below. Now, if your point is on whatever line you're reflecting over, then it's not going to move, right? Okay, because it has a distance of 0, so it's going to stay a distance of 0. All right, so now to reflect a figure over a horizontal or vertical line, you can simply count the distance, all right, from the original figure, original point to the reflected line, and then count the same distance, right, on the other side of the reflection line. All right, and so once again, and that should make sense because if we were to fold along that reflection line, we want everything to match up, and the only way that can happen, right, is if that pre-image and image are the same distance away from your line of reflection. All right, so let's go through a few examples here. All right, so let's drop down to number 1 here. All right, so we want to reflect the given points over the x-axis. So let's start with J here, which is 3, 4. So 3, 4, there's point J. All right, and I'm just going to grab my highlighter right here, and we're reflecting over the x-axis. So there's my line of reflection. All right, and so I want to count the distance to that line, and then I'm going to go to the other side of the line the same amount. All right, so I'm going to go 1, 2, 3, 4, and then I'm going to go down 1, 2, 3, 4. All right, and so there would be J prime. All right, so if we take O, which is 5, 6, which would be right here. All right, I'm going to count the distance to that line of reflection and then perform the same distance on the other side or go the same distance to the other side. So that would be 6 above. So I'm going to go 1, 2, 3, 4, 5, 6 below. All right, and if I have -3, -5, so -3, -5 would be right here. So there's B. And notice this time I'm 5 units below. So to reflect it, I would want to be 1, 2, 3, 4, 5 units above. And then there's B prime. All right. Okay, so here's what I would like you to do. All right, I want you to do number 2 real quick. All right, so I want you to pause the video and you're going to reflect those same points, but this time you're going to reflect them over our y-axis here. All right, so I want you to pause the video, reflect those 3 points over the y-axis, flip it back on, and we'll see how you did. All right, so going back to our graph here, hopefully, all right, your work looks like my work, right? So J is 3 to the right, so J prime should be 3 to the left. O is 5 to the right, so O prime should be 5 to the left. B is 3 to the left, so B prime should be 3 to the right. And that's all reflection is. All right, so let's go to the next page. Let's go to problem or page 3 here. All right, now we're going to reflect these points, but now notice this time we're going to reflect over the line x equals 1. All right, so we're going to go over the line x equals 1 right here. All right, grab my highlighter. All right, and then I'm going to highlight that as well after drawing it in. So there's our line of reflection. All right, so H is 2, 5, so right here. So 2, 5. All right, so notice H is 1 to the right, so H prime has to be 1 to the left, just like that. So O, all right, is 4, -5. So 4, -5. All right, so there's O. So O is 1, 2, 3 units to the right, so O prime has to be 1, 2, 3 units to the left. T is 1, -2. So 1, -2 would be right here. So notice that T is on the line of reflection. So when we reflect it over x equals 1, T and T prime would be exactly the same. All right, okay. So I would like you to, same thing as before. Now I would like you to pause the video and I would like you to do number 4 on your own. And then once again, notice you are going to reflect over the line y equals 2. So let me draw in y equals 2 right here. All right, so that's your line of reflection. So reflect those 3 points over the line y equals 2. Flip the video back on and we'll see how you did. All right, so hopefully, all right, your work looks like my work. All right, so H was 3 above, so H prime should be 3 below. T was 4 below, so T prime should be 4 above. O was 7 below, so now O prime should be 7 above. All right, so hopefully that gives you a really good feel, all right, over, all right, how to reflect points. And then when we come back to class, what we'll do now is we're just going to take this, right, and we're just going to apply this to figures, all right, and it doesn't really matter what shape we have, all right, because notice we could have connected, all right, our 3 original points and made a shape. So the way we reflect a figure, all right, is we just take those 3 points or 4 points or however many points we have in that figure, and we just reflect them individually to get our, all right, image, all right, to be reflected. So that wraps up our lesson on reflections. All right, I will see you guys next time.